So by the time I'm recording this, it's the end of the emo phase, which is why you see me in white instead of black. So it's time to get rid of this tattoo. It is a purple, by the way, and this is washing marker. Raymond, keep the change. From your non-existent waifu, eternal singular.
Hello, darkness, my old friend!
So for part A, we are looking for the mass of the cable. So, out of all the givens, we're only given length, diameter, and density. So first, we get, we have the density of the cable, and that's basically the mass of the cable divided by the volume of the cable. So we are given the density of the cable, which is 5,000 kilograms per meters cube, but we aren't given we aren't explicitly given the volume of the cable. So yeah, they gave us the length, which will be the height of the cable, which is basically just a longer cylinder. So and we are given the diameter of the cable, since again it's a cylinder. So if you cut the diameter in half, you get 0.015 meters. Um, so yeah. Now that we have R and H, which in this case is L, the length of the cable, um, uh, we can plug in 0.015 for R, uh, and then we can just plug in 2,831 meters for L, and L in this case is H. So yeah, and I don't know if you guys got the same answer as me, but I got about um I got about 2.0012 meters cubed, uh, which to me is a little alarming because if you go to significant digits by two decimal places, it's just two. So two is the volume that I got. So and now we have to isolate mass from. So we multiply both sides by the volume of the cable. So so yeah. Now the mass of the cable is isolated. So we plug in the volume of the cable, which is 2, and then we can plug in the volume, the density of the cable, which is 5,000 kilogram meters per second, 8 meters cubed. Excuse me. Oh yeah. By the way, I forgot to tell you that the unit for the volume of the cable is meters cubed. So yeah, and then you multiply both of those, and then I got 10,000 kilograms. You guys probably got something different, but anyways, yeah, that's my answer for part A. So at the time this is being recorded, it's 3 a.m. and I already feel cursed before I started recording. So for part B, we are calculating the linear mass density of the cable. So it's represented by mu here. So we need the answer for part A to get the answer for part B, since yeah, we already calculated the mass, which is the mass of the cable, which is 10,000 kilograms, and then we are already given length, so L equals 2,831 meters. Yeah, just divide it, and you would get I, I got 3.53 kilograms per meter. It's actually meter, not meters cubed. That is me mistake. So this is my answer for part B. So for part C, we are looking for the speed of the disturbance on the cable. So basically the speed of the wave instead of the speed of the amplitude, which is different. So yeah, that's obvious. Don't mind that. So it's calculated as the square root of the ten of the quantity of the tension first divided by the linear mass density uh thing. So yeah, the 110,000 newtons is the force of the tension, and it's being divided by the linear mass density that we just calculated earlier. So yeah, so if you do this right, uh, the velocity would the velocity would be 176.53 meters per second. You guys probably got a different answer, but that's what I got, and I'm barely right. So yeah, and now for part Now for part D, we are looking for how long it takes for a pulse to traverse the span of the cable for the cable car that goes through the Geant Glacier on Mont Blanc. It's been a long time since I've been threatened by a green bird to speak French. So yeah. Anyways, sorry for the dead meme, but yeah. So we are given that the velocity is equal to the distance over time. S is just the general term for distance, so yeah. But for S here, we are referring to the length of the cable, which is L, and yeah. So right now we are looking for T, so we have to isolate the T first. So basically you divide both sides by V and then multiply both sides by T, aka just swapping V and T. So yeah, time equals length divided by volume. So plug in 28.3, no, 2,831 meters for the length, and then the velocity is 176.53 meters per second as we calculated in part C, and and then I got 16.04 seconds, and that's me as of part D.